Hello students, this is our fourth class of the chapter Polynomials. For better understanding, you see the videos of the previous three classes. The link of the videos of the previous three classes is already given in the description. You see it so that you will understand all these concepts properly. In the last class, we have studied the relationship between zeros and coefficients of linear polynomial, quadratic polynomial, and cubic polynomial, and we have solved the questions for the verification of the relationship between zeros and coefficients of a quadratic polynomial. In that, we have also studied how to find out zeros of a quadratic polynomial and verify the relationship between zeros and coefficients. Today, we are going to do some more questions of cubic polynomial. So let us start with the questions. So the first question here is verify that 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial p of x equals to 3x cube minus 5x square minus 11x minus 3, and then verify the relationship between the zeros and the coefficients. So first of all, we have to verify that the given numbers are the zeros of the given cubic polynomial, and after that we are going to verify the relationship between zeros and the coefficients of the given cubic polynomial, right? So let us start with this. First of all, let us write the given polynomial p of x, which equals to 3x cube minus 5x square minus 11x minus 3. Now let us verify whether the given numbers are the zeros of this cubic polynomial or not. So let us first of all start for 3. So we know that for a given number, if the value of the given polynomials becomes 0, then it is called as 0 of the given polynomial. So we are going to start from 3. So let us put x is equal to 3 in the given polynomial and do the calculations. For 3, if the value of the given polynomial becomes 0, then we can say that 3 is a 0 of the given polynomial. And in the same way for the remaining two numbers, right? So let us start it for 3 first. If we replace x with 3 in the given polynomial, then we will get it like this. Then let us do the calculations. Wherever x is there, x will be replaced by 3 at all the places, and doing the further calculations we'll get it like this. So first of all, when we'll replace x with 3, we'll get 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. Then next step we'll be doing the calculations, and doing the calculations we'll get it 81 minus 45 and minus 33 minus 3 is nothing but minus 36. Solving this, we'll get p of 3 is equal to 0. Now it means that value of the given polynomial at x is equal to 3 is 0. It means that 3 is a 0 of the given cubic polynomial, right? Similarly, we'll do for minus 1. We'll put x is equal to minus 1 in the given polynomial. So we will get 3 into minus 1 cube minus 5 into minus 1 square minus 11 into minus 1 minus 3. And then we will do the calculations of this. Doing the calculations, we'll get 3 into minus 1 minus 5 into 1 minus 11 into minus 1 will get plus 11 minus 3. Again doing these calculations, we'll get p of minus 1 equals to minus 3 minus 5 plus 8, which will give us 0. So value of given polynomial at x is equal to minus 1 is 0. It means that minus 1 is also a 0 of the given cubic polynomial, right? Now let us check for the third number. Our third number is minus 1 upon 3. So we'll put x is equal to minus 1 upon 3 in the given polynomial. So p of minus 1 by 3 is equal to, we'll get 3 multiplied by minus 1 upon 3 cube minus 5 into minus 1 upon 3 square minus 11 into minus 1 upon 3 minus 3. And again, if we calculate this further, we'll get 3 multiplied by minus 1 upon 27 minus 5 into 1 upon 9. It is the square of minus 1 by 3 plus 11 by 3 minus 3. Again calculating this, we'll get minus 1 upon 9 minus 5 by 9 plus 11 by 3 minus 3. By using the method of LCM, you can equate all the denominators and solve this. Solving this, we'll be getting it like this. See, minus 1 upon 9 minus 5 by 9, we can write minus 6 upon 9. 11 upon 3 we have written as it is minus 9 by 3. So further, if we solve this further, we'll get P of minus 1 upon 3 is equal to minus 6 upon 9 is nothing but minus 2 by 3. 11 by 3 minus 9 by 3 is also 2 by 3. Solving this, we'll get P of minus 1 by 3 is equal to 0. It means that minus 1 upon 3 is also a 0 of the given cubic polynomial, right? So in this way, we have verified that 3, minus 1 and minus 1 upon 3 are the zeros of the given cubic polynomial. So this is the first part of this answer. Now second thing, we have to verify the relationship between zeros and coefficients of this cubic polynomial. So we have got all three zeros of this cubic polynomial. The zeros are respectively 3, minus 1 and minus 1 upon 3. So let us call alpha as 3, beta as minus 1 and gamma minus 1 by 3. And then we will verify relationship between zeros and coefficients. Now let us start the verification part. In the verification part, first of all, let us go for the sum of the zeros. That is nothing but alpha plus beta plus gamma. We have considered alpha as 3, beta as minus 1, gamma as minus 1 by 3. It doesn't matter even if you change the order. And doing the calculation, we'll get that this value is equal to 5 upon 3. So let us call this as equation number 1. Now we have to show that sum of the zeros, that is alpha plus beta plus gamma, is equal to minus b upon a. That is nothing but negative coefficient of x square divided by coefficient of x cube. So minus coefficient of x square is minus 5. So minus of minus 5 divided by coefficient of x cube is 3. So that is equal to 5 upon 3. Let us call this as equation number 2. So from equations 1 and 2, we can see that both the values are equal. It means that we can say alpha plus beta plus gamma is equal to minus b upon a, right? That is negative coefficient of x square divided by coefficient of x cube. Next, let us verify the second relation, that is sum of the product of the zeros taken 2 at a time. That is nothing but alpha into beta plus beta into gamma plus alpha into gamma. So first of all, let us put values here. So alpha is 3, beta is minus 1. So 3 into minus 1 plus minus 1 into minus 1 by 3 plus 3 into minus 1 by 3. Again, solving this further, 3 into minus 1 is minus 3. Minus 1 upon minus 1 by 3 is 1 by 3. And 3 into minus 1 upon 3 is minus 1. Okay, so calculating this, we'll get it is equal to minus 11 upon 3. So let us call this as equation number 3. Now we have to show that it is equal to c upon a, that is coefficient of x divided by coefficient of x cube. So coefficient of x here is minus 11 and coefficient of x cube is 3. So now from equations 3 and 4, you can see that both the values are equal. It means that alpha into beta plus beta into gamma plus alpha into gamma is equal to c upon a, that is nothing but coefficient of x divided by coefficient of x cube, right? So next part, let us start with the third relation, that is product of the zeros, that is alpha into beta into gamma. So that is nothing but 3 into minus 1 into minus 1 upon 3. So doing this calculations, 3 will get cancelled. Minus 1 into minus 1 is plus 1. So let us call this as equation number 5. And we have to show that it is equal to minus d upon a, which is nothing but minus of constant term divided by coefficient of x cube, that is minus of minus 3 divided by 3. Constant term there is minus 3, right? You can see the given cubic polynomial. So 3 upon 3 will get it is equal to 1. So from equations 5 and 6, we can say that alpha into beta into gamma is equal to minus d upon a. So this is the way in which we can verify that the given numbers are the zeros of the given cubic polynomial, and also we can verify the relationship between zeros and coefficients of a cubic polynomial. So this is very easy part to do. Now this is the verification. Okay, we have three relations for cubic polynomial and coefficients. Okay, zeros and coefficients of a cubic. Now we are going to see some very important concepts which we will require in the further questions. In 9th standard, we have studied the factor theorem. So first of all, we'll start from the factor theorem. We'll write that as note number 1. We know that if alpha is a 0 of a polynomial p of x, if alpha is 0, then we know that p of alpha must be equal to 0. And it means that x minus alpha is a factor of p of x. So this we can write by using factor theorem. If alpha is 0 of p of x, then x minus alpha is a factor of p of x. So variable, first of all, we are writing as it is, and whatever 0 is there, we are writing the opposite sign of that 0. So x is the variable, so first of all we have written x. Alpha is 0 of p of x, so we have written minus alpha in front of x. If minus alpha is 0, then we would have written plus alpha before it, right? So we have seen the factor theorem. If alpha is a 0 of a polynomial p of x, then x minus alpha is a factor of p of x. Second note, similarly, if we have given two zeros, that alpha and beta are the two zeros of a polynomial p of x, then definitely it must be a quadratic polynomial, right? So if alpha and beta are the two zeros of a polynomial p of x, then we can say that x minus alpha into x minus beta is a factor of p of x, right? So this is the second thing which we have seen. This is again the advanced mode of the factor theorem. Factor theorem we have seen for 1 0. So if similarly if you are given two zeros, then from that two zeros we can write it that if alpha and beta are zeros, then x minus alpha into x minus beta are the factors of p of x. Now we have seen the first part of this chapter. We have studied that if we have given a quadratic polynomial, we can find out its zeros by using the method of factorization, that is splitting middle term. Now today we are going to see the converse part of that. Means if will be given the zeros of a polynomial, okay, suppose we have given that alpha and beta are the zeros of a polynomial p of x, then from that how can we write the polynomial? Getting it? The first part we have seen, from polynomial we can obtain the zeros by factorization. But if we have given zeros, can we write the polynomial which will be satisfied by that zeros? So this we are going to study now. So let us see note number 3. If alpha and beta are the two zeros of a polynomial p of x, then we can write a polynomial having alpha and beta as zeros, right? So let us see the method. How can we do this, right? So let us start. If alpha and beta are the zeros of the polynomial p of x, then next step we can write is x minus alpha into x minus beta is a factor of p of x, right? Then let us multiply these two brackets. Multiplying the brackets, we will get that this p of x is equal to, okay, now it is factor, so there may be some other number also, something, let us say k. We are going to add it in the end. So let us simply do the multiplication of these two, okay, because we have got that x minus alpha into x minus beta is a factor of p of x. So there may be some real number, or there may be some multiple k, let us say any real number k, which can be multiplied to this product, which we are going to put it in the end. But till now that p of x will just consider as x minus alpha into x minus beta, or if you wish you can put k here also, that k is the number which needs to be multiplied to these two factors to get the original polynomial, that is p of x, right? So multiplying these two, we will get p of x is equal to x square minus alpha x minus beta x plus alpha into beta, right? So again here what we can do is, okay, this is simply the multiplication of the brackets. Now from the second and third term we can take x common, as well as we can take minus sign common. So if we do that, we'll get p of x is equal to x square inside the bracket alpha plus beta into x, right? We have taken minus sign and x common, so inside the bracket alpha plus beta will remain because we have taken negative sign common. Whenever we take negative sign common out of the bracket, sign inside the brackets will be changed. Then plus alpha into beta. So this is the polynomial which we require, and we again have to write that multiple k which we are going to add here. Okay, so p of x will be written as k multiplied by x square minus alpha plus beta into x plus alpha into beta, right? So this is the required polynomial where k is not equal to 0. So this is the formula we can say, yes, which will give us the polynomial if we have given the zeros. So in other ways we can write the polynomial p of x is equal to k multiplied by x square minus alpha plus beta is nothing but sum of the zeros into x, that is the variable of the given polynomial, plus alpha into beta is nothing but product of the zeros. So this is the formula to write a polynomial if we have given zeros. Okay, so if we are given two zeros of a quadratic polynomial, we can write the polynomial by using this formula. So to write that, first of all we'll require sum of the zeros, then we'll require product of the zeros, and k is any real number except 0. So for the given two zeros, we can write n number of polynomials which will be satisfied by those zeros. So there will be infinitely many polynomials having the same two zeros, because we can put any real number in place of k except 0. So this is the formula, remember it. If we have given alpha and beta as zeros of the given polynomial, from that polynomial first of all we'll from the zeros, first of all we'll write sum of the zeros and then product of the zeros, and from that we can write a polynomial which will be satisfied by the given zeros, right? So now let us see some questions based on this concept. Question number 1 is find a quadratic polynomial if its zeros are -2 and 1 respectively. So we have given the zeros and we are supposed to write the polynomial, right? So here let us say one zero is alpha and another one is beta. So let us say alpha is equal to -2 and beta is equal to 1, right? Now in order to write a polynomial, we know that first of all we'll require sum of the zeros and then we require product of the zeros. So let us start with this one. Let alpha will say as -2 and beta as 1 are the zeros of the given polynomial p of x. In order to write the polynomial, first of all we'll require sum of the zeros, that is alpha plus beta, which is equal to -2 plus 1, which is nothing but -1. And second thing which we require is alpha into beta, that is product of the zeros, which is -2 into 1, which is nothing but -2. Now let us write the formula. Formula to write the polynomial is p of x is equal to k multiplied by x square minus alpha plus beta into x plus alpha into beta, where k is not equal to 0, right? So let us put the values now. So k will write as it is inside the bracket x square minus sum of the zeros, that is alpha plus beta is -1, just put that value there, into x plus alpha into beta is -2. So that value also we are writing as it is. Now let us do the calculations. So we'll get p of x is equal to k multiplied by x square minus minus will become plus. So plus 1x, that is nothing but plus x, and plus into minus is -2. So here we will take k equal to 1. You can take any value for k, doesn't matter, but for sake of simplicity, as there are no denominators, simply we'll take k equals to 1. Putting k equal to 1, we'll get p of x is equal to x square plus x minus 2. Okay, that is what I said. You can put any real number for k except 0 and you will get n number of polynomials which will be satisfying the given two zeros, right? So this is the way of finding the quadratic polynomial if its zeros are known to us. Now let us see another question. Now it is a bit different question than the previous question. In the previous question we were given the zeros, that is alpha and beta were given to us, and from that we found sum of the zeros, then we found product of the zeros, and from that we wrote the polynomial, right? Now see the change in this question. Question number 2 is find a quadratic polynomial with the sum and product of its zeros as -3/2 and 2/3 respectively. So here directly we have given sum and product of the zeros of the given quadratic polynomial. So here we do not have to find out sum and product differently. It is already given to us, right? So we'll begin in the same way. So let us say that let alpha and beta are the zeros of the given of the polynomial p of x. Let us say the given quadratic polynomial or required quadratic polynomial is p of x, right? We have given sum of the zeros as -3/2 and product of its zeros as 2/3. So we have given alpha plus beta is equal to -3/2, which is sum of the zeros, and alpha into beta as 2/3, which is product of the zeros. Now we know that in order to write a quadratic polynomial, we always require sum of the zeros and product of the zeros, and both the things are with us. So let us write the formula now. The formula to write a quadratic polynomial from the zeros is p of x is equal to k multiplied by x square minus sum of the zeros, that is alpha plus beta, into x plus product of the zeros, that is alpha into beta, where k should be non-zero. Just put the values in it. So p of x is equal to k multiplied by x square minus alpha plus beta is minus 3 by 2 into x plus alpha into beta is 2 by 3, right? So p of x is equal to k multiplied by x square plus 3 by 2 into x plus 2 by 3. Here we have a bit scope to choose the value of k in order to write the integer coefficients. So in order to write integer coefficients of all the variables, we can take the LCM of the denominators. Denominators are 2 and 3, their LCM is 6. So we can choose k equal to 6. So if you put k equal to 6, then this polynomial will multiply by 6 to all the terms. Okay, so 6x square, 6 multiplied by 3 by 2 is nothing but 9. So 9x, and 6 multiplied by 2 by 3 is 4. So by putting k is equal to 6 in the above statement, we can get given polynomial as p of x is equal to 6x squared plus 9x plus 4. As we have discussed earlier, you can put any other value for k. It is not like that you have to put the LCM only. You can take any value for k. You can take 1 also. Except 0, you can put any real number as the value of k, and that will be the polynomial satisfied by the given two zeros, right? So this is the way of finding the answer. Okay, so we have seen two types of the questions. First type, if zeros are given to us, then how to write the polynomial. Second, if sum and product of the zeros is given to us, then how to write the polynomial. So with this note, we'll end for today. So today's homework is this. You solve all these questions for homework, okay, and practice it well. Thank you.